All right, welcome to Module 4.3. The question is, what does it mean to be rational? That's going to be something that we're going to be highlighting today. What is a rational number? What is a rational expression? How do we deal with the rational expression? And are they functions? So anyways, start off by turning to page 15 in your packet, and we're going to complete questions 1 through 6. So it says use long division, and it's been a while since we used long division, so I'm going to give you guys the first example, and then I want you guys to try the other ones by yourself. So it says use long division to determine if the linear term is a factor. Now, if something is a factor, that means that, well, will it have a remainder? No, well, the remainder will be 0, right? So that's what we're basically looking for. So here we go. I got x plus 2, and I have to divide that by x cubed plus 6x squared plus 8x. Okay, so starting off with this, I just want to double check that there's a descending order of the powers, or otherwise we'd have to put in like a 0 x squared or a placeholder of some sort. So looking at this, how do I get from x to x cubed? What would I have to multiply that by? So we get x squared, so x squared times x would give me x cubed. So remember, when we're using this long division method, we're multiplying that times that and also by the 2. So if I have x squared times 2, that's going to be positive 2x squared. Now at this stage, we're going to subtract or take the opposite of both of these terms, so this becomes minus and this becomes minus, and I'm going to need some more room here. So I'm going to get rid of question number 4. So we go like this, those cancel, and then we have 6x squared minus 2x squared. That's going to be 4x squared. I'm going to bring down the 8x. And now I look back at the beginning and I say, okay, how do I get from x to 4x squared? Well, I'd have to multiply it by a positive 4, and then also I'd have to multiply it by an x. So then we multiply. So 4x squared, 4x times 2 would be a positive 8x. Don't forget to take the opposite. So when we take the opposite, this becomes the opposite and this becomes the opposite. And we see that those cancel out and we get a remainder of 0. So what does that mean? X plus 2 is a factor. All right, so we could say yes, it is a factor. And why don't you guys try the other 5 of these and see if they work. Hey, how about this? Why don't we do at least 2 of them with long division? Okay, and then the other ones you guys can try using synthetic division, because I know you're probably thinking, Mr. Wilson, how come I can't just use synthetic division? So much easier. It is so much easier, but we want to stay fine-tuned with our skills with the long division. So go ahead, give it a shot, and we'll check the answers in a minute. All right, with our answers all done in our packet, we already know that this one was a yes. This one right here was also a yes. X plus 7 was a factor here. For number 4, x minus 3 was not a factor. And for number 5, this was a factor, and this one was a factor. So check your answers. Double check. Your partners are checking as well. Just check everything. Speaking of checking, let's go ahead and check your homework. So last night we did this and we found the domain, hopefully, and there's the answers to that. Remember, you can access this on the website, so check it. And then this one right here, we already had that answer here, and then bam, bam, there we go. Okay, so on the website, these are also available. If you guys have questions, just ask me or come and see me at lunch or after school, and we can get those questions resolved. All right, so 4.3 says, what does it mean to be rational? So you guys should have got a worksheet, so we are going to talk about that here for a second. When it comes to a rational number, what is a rational number? So in your own words, what I want you guys to do is define what you think a rational number is. So take a second. What is a rational number? Write it down right here. What is a rational number? So when I think of a rational number, typically I think of like a fraction. Okay, so a fraction is a rational number. Now if this is a rational number, then that means that its counterpart, right, its decimal, is also going to be considered a rational number. Okay, so basically anything that can be written as a fraction is considered a rational number. So we have to think about a number like 2. Is 2 a rational number? Well, can we write this as a fraction? Yeah, we can write this as a fraction where it's 2 over 1. So in your own words, hopefully you wrote something like that. Anything that can be written as a fraction. So now I want you guys to look down here where it says circle the numbers below that are considered rational, and maybe refine your definition if needed. So go ahead and take a second and do that, and then we'll check and see if we're all on the same page. Alright, so 3 is obviously a rational number because it could be written as a fraction. So is -5, 2/3, 20 over 3. 14 can be written as a fraction. What about 2.7? Well, yeah, it's considered a fraction when you convert the 7/10, right? So then what about the square root of 5? Well, that's an irrational number. So 2 to the 3rd power is 8. This right here, what does the negative do? Yeah, the negative is going to take the reciprocal, so we know that that's going to be a rational number. Now, if we evaluate this logarithm, 2 to the what power would give us 8? Yeah, it's 3, so that also is a rational number. Now, what about 7 over 0? Can I divide by 0? Yeah, no, that's going to cause an error. So, good job. Let's move right along. It says the definition of a rational function is as follows. It says the function f of x is called rational function if and only if it could be written in the form where you have p of x. Now we've seen p of x and q of x before. Now it defines it a little bit more right here. It says where p and q are polynomials. And we know what a polynomial is because that's fresh in our mind from module 3. So a polynomial is variables that are either multiplied or some sort of operation like addition or subtraction between other variables and numbers. Okay, so that means that there has to be an x in the denominator and an x in the numerator. Or, well, the x in the numerator doesn't necessarily have to happen, just an x in the denominator. Okay, and as long as there's no 0 in the denominator. So let's try to put this in our own words, and maybe you guys can give me some examples of rational number or rational functions, okay, down right there. So just since it's fresh in your mind, go ahead and write a couple examples right there on your paper. Okay, so number that can be made into a fraction, and there we go. It says how are rational numbers and rational functions similar and are different? So we're going to try to analyze this because right here we have 2 fractions that are being added together, and then over here we have 2 rational expressions that are being added together. So watch this. Over here, when I have 2/3 plus 4/7, we need to find an LCD. So in order to find an LCD, we got to think, okay, what's a number that 3 goes into and 7 both go into? And so you should have, well, maybe you're thinking as well, 21. So that means that 3 needs to be multiplied by 7, and so does the numerator. So then we have 7 times 2, that's going to be 14 over 21. And then over here, this has to be multiplied by 3, and this has to be multiplied by 3. So we have 12 over 21. Now that the denominators are the same, we can then just add the numerators. So the notice that the denominator, even though there's 2 of them, right, we're only writing it once, and then up top, we're going to have 26. Okay? So now over here, the same thing works with these guys. Okay? So if I have x plus 1 and x minus 1, these are not the same denominator, because if x was 2, we would come up with 2 different denominators. You see how this would be 3 and this would be 1? So we can't say just because they almost look alike, all right? And I mean, you guys should know what these are anyways, right? Conjugates. They're not the same thing. So since 3 and 7 aren't the same thing, all we did is just take the 3 and multiply it by the other denominator. So that's what we're going to do here. We're going to multiply this side by x minus 1, and so we have to multiply the top by x minus 1. Okay, and over on this side, we have to multiply this by x plus 1 and the top by x plus 1. Okay, same type of thing as what we did over here. And so now let's try to clean this up a little bit. X minus 1 times x plus 1, we know that that's going to be x squared minus 1. That's the conjugate rule. Okay, and then we have x minus 1 times 3, so that's going to be 3x minus 3. And over here, that's going to be 4x plus 4. 4. There we go. Okay, are the denominators the same? Just like over here. So what did we do? We kept the denominator the same, and we just added the numerator. So we have x squared minus 1, and up top we have 3x plus 4x, so that'll be 7x, and then negative 3 plus a positive 4. Notice that I'm considering the sign for both of them. So if this were a negative, we'd have to kind of distribute the negative to both of these terms. Okay, so a negative 3 and a positive 4, that's going to be positive 1. So that's how we would do that for the arithmetic, or adding two rational expressions. So there's one right below. Why don't you guys go ahead and see if you can try to do this one here. So over here, we're not just necessarily multiplying these two, because that wouldn't be the LCD. Okay, so what's a number? The least, that's what the L represents, the least common denominator here, or factor, multiple, or factor that, I got it, okay, that both of these go into, and both of them go into 24. Okay, so instead of multiplying it by 6, we can multiply it by 3. And over here, instead of multiplying by 8, we could multiply this by 4. Okay? So I'm not going to finish this one because I feel like you guys know how to do that. And over on this side, do you guys see how we have a common factor of x plus 3 and x plus 3? So I don't need to multiply this whole denominator times this whole denominator. We just have to make this denominator kind of look like this one. So what is this one missing that this one has? See, this one over here is missing the x minus 1. So I'm just going to multiply it by x minus 1 on the top and bottom. Okay. Now once I do that, I'm going to go ahead and distribute, so that'll be 2x squared minus 2x divided by x minus 1 times x plus 3. Now notice that looks exactly like, or at least the denominator, right? So we don't have to do anything to this fraction over here. Right? So now that the denominators are exactly the same, we could just add the numerators. Now I'm just going to keep the LCD down here. Okay, just trust me. Our LSD. What the heck? Gosh. Here we go. I got LCD. There it is. Okay, I'm just trying to keep you guys on your toes. Okay, I want you to be anyways. All right, so 2x squared plus 4x minus 2x. So we can go ahead and subtract those. And so we get 2x squared plus 2x over x minus 1 times x plus 3. Okay. Now, I always like to look and see, man, is there a way that I could possibly divide out something on the bottom? Okay, so see how this is a x minus 1? Up top, see it has a common factor. Like I could factor the top and put, let's say if we pulled out a 2 and an x, then I'd be left with an x and a positive 1. Okay, now that doesn't divide out with anything in the denominator, so I'm not even going to worry about factoring the top. All right, so keep going. Now we have subtraction. Okay, try number 6a on your own time and 6b. I'm going to quickly look at 7a. We have multiplication. Whenever we're multiplying fractions, it really just works like this. 3 times 5 divided by 8 times 6. Okay, so then that would be 15 over 48. Now this can be reduced. Now either you can reduce it at this stage, or you could reduce it at this stage. I like to reduce it at this stage because it just seems easier. Okay, so I know that 3 has a common factor in 6. 6 is the same as 2 times 3. So I could cancel out this 3 with this 3, okay, and the 5 can't cancel out with anything else. So I know that the simplified version of this would be 5 over 8 times 2, which is 16. So we could do the same exact thing here. I know that on this side, we're multiplying straight across, okay? So before I multiply all those numbers together, I'm just going to see if there's any common factors on the top and the bottom. So like, for example, this x minus 2 and this x minus 2 can cancel out. Is there anything else? Yeah, no. Okay, so we've got x plus 1 and x plus 5. And we're going to just leave it in factored form. And then down below we have x plus 2 and x plus 2. Okay? All right. Question number 8. it's division. So one of the rules that we learned is that whenever we're dividing two fractions, we just multiply by the reciprocal, or what I say is MBR. So multiply by the reciprocal. So keep 3/8 exactly the same, and now you're going to multiply, instead of division, you're going to multiply by the reciprocal here, which is going to be 6/5. Okay, so we're going to do the same exact, and then you just finish it up like multiplication. So we're going to do the same exact thing over here. We got x plus 1 and x minus 2 and x plus 2. We're going to keep this one exactly the same, but now we're going to multiply by the reciprocal here. So we have x minus 2, x plus 2, divided by x plus 5. I just want you guys to notice right now that when it's in factored form, it's so much easier, because now we could look back and say, okay, these divide out. So the first thing is, whenever you're dealing with these, is, man, just factor the top and the bottom of each of the rational expressions, okay? Because now what we're going to do is this x plus 2 can cancel with this x plus 2. Hey, could this x minus 2 cancel with this x minus 2? Yeah, this one cannot, because they're both on the top at the same time. Now, if one's on the bottom, then they can cancel out, because we know that like 5 divided by 5, that cancels out, not 5 times 5. We can't say 5 times 5 cancels out. Okay, so in the same way, we can't do that as well. All right, so we just cleaned it up, and you got x. Let's see, x plus 1 times x minus 2 squared, and then divided by x plus 5. Okay, so double check with your partners. Make sure you guys get it. Maybe have a little conversation and talk about what we just learned so far. All right, so let's summarize what we've learned so far. So on one side that we have right here, it's talking about rational numbers, and on this side it says rational expressions. So rational numbers don't have any variables, and the expressions, they do have variables. So whole numbers are just are rational numbers with a denominator of 1. So that means anything that you can make into a fraction. Now, in the same sense, rational functions are the same, but just remember, like, they're the same, but we have to keep a variable in the denominator. Okay. So over here, it gives you the rational expressions. Okay, another like quality. It says rational expressions are undefined when the denominator equals 0. Now, is that true for rational numbers? Yeah, that's true. Okay, so there's a lot of similarities across the board. So notice that when you add, subtract, multiply, or divide two rational numbers, the result is also a rational number. What do you guys think is going to happen with rational expressions? Yeah, man, the same stuff. Okay, rational fractions are classified as proper fractions when the numerical value of the numerator is smaller than the denominator. Okay, so do you remember improper fractions? Improper is when the numerator is bigger than the denominator. So the same thing works on both sides. Okay, so let's summarize here. It says, when it comes to adding, what would we do? If there's two rational expressions that we're adding together, what do we need to find? Well, think back to rational numbers. What did we find? Okay, we found the LCD, right? And once we had the LCD, we add the numerators. Okay, what about subtracting? Same thing, right? We found the LCD, okay, and then subtract the numbers. And what about multiplying? Did we need to find the LCD? No, we just multiply straight across, right? Multiply the numerators, then multiply the denominators, okay, horizontally. And then dividing, we're gonna do MBR. Okay, so multiplying by the reciprocal and then horizontally across. So you're going to flip it. Now, oops, let me go back here. I want to just practice real quick finding the LCD when we've got different LCDs. So let's say that we had the denominator of x and then another one had a denominator of x. What would be the LCD? Yeah, they're both the same, right? So the LCD is x. Okay, now what about if this was a square? What would be the LCD between x squared and x? Would it still be x? Okay, well, let's think about it in terms of numbers. If I had, let's say 25 and 5, isn't 25 5 squared? What would be the LCD between 25 and 5? It would be 25, right? So the LCD between these two would be x squared. So if I had x minus 2 and x plus, that's a plus, plus 3, what would be the LCD? just be the product of both of these, okay? And think if the denominators are different, like if I have 2 and one of them is 3, it's the product of both of these. The LCD would be 6, which is 2 times 3. So over here, LCD is x minus 2 times x plus 3. Okay? What if there was an x minus 2 and then on this side we had an x plus 3? What would be the LCD now? It would still actually be the same thing. All we would have to do to this denominator is we'd have to multiply it by x minus 2 on the numerator and the denominator. Okay? All right. So what if I had x squared y cubed, and on this side was y to the 4th x? What would be the LCD? I don't know what that is. Okay, look, you're just going to take the highest degree, right? So LCD would be x squared, just kind of like what we did up here. And then what's the highest degree between the y's? The 4th. Okay? Now how would you like then play with this and say, okay, well this one already has the x squared. What it's missing is one of the y's, so you'd have to multiply this by y on top and bottom. And over here, what is this one missing? Well, it already has the y to the 4th, but it's missing an x, so we'd have to multiply this and that by x. Does that make sense? Of course it does. All right, so go ahead and take out your packet. We're going to turn to page 15 and 16. That's going to be your classwork. Notice what it says. It says define the rational expression and give 3 examples. Okay, 2 proper and 1 improper. So this one right here, this is like an example of right here. This is an improper rational function. Okay, so take some time, work on this. You guys can access the answers on my website. And good luck, and I'll see you next time.